This is Unit 5. Unit 5, I told you, would be very different from the previous units. We're not looking at one individual, we're looking at interactions between individuals, or groups of individuals. This picture here is one of my favorites of all time. It doesn't look like there's very much going on, but right over here we have this one little spot of light, and this little spot of light is us. So this picture was taken in 1990, and it was taken from 6.5, almost billion kilometers away. Voyager 1 is now much further than that away. It continues going out into deeper space. And this picture, I think, serves as a pretty good transition into the next unit, because the next unit is looking at this concept called the biosphere. The biosphere being all of the living and non-living components of the Earth that interact in order to allow life to exist. So that it contains things like the soil, what's in the air, what's in the water, and all of those things interacting with each other are complicated. There are some terms we'll need to know. One of those terms is producer. Producer has its opposite, which is consumer. And for producers and consumers, it's probably smarter if I highlight producers and consumers. For producers and consumers, there are some different categories of each. Producers are things that produce their own food. If you're a producer, you are called autotrophic. Auto meaning self, and troph for feeding or nourishing or growing. The most common way we know of to do autotrophism is by photosynthesis. So photosynthesis is the opposite of the process of cellular respiration. Photo-autotrophs, so if we break this into sections, photo, auto, and troph. Photo being light, talking about photons, auto for self, and troph for feeding. These are organisms that use light to feed themselves. There are other types of organisms that we know about called chemo autotrophs, and they use chemicals to feed themselves. And we didn't know about these until fairly recently, looking way deep down under the ocean, where we expected to find no life at all. We found some that was growing, and we didn't really figure out for a while what was going on there. We thought maybe there was some stuff that was alive on the surface that had sunk down to the bottom, but it turns out that there are whole ecosystems that are surviving deep down where there is no sunlight at all, and the producers are called chemo autotrophs. They do a process called chemosynthesis. We know the word synthesis from before. Synthesis meant to build, to make. We learned that from the dehydration synthesis reactions on the very beginning of the course. So consumers have some categories. All consumers are called heterotrophic, hetero meaning other, and troph meaning food. So we are heterotrophic, other animals are all heterotrophic, fungus, bacteria, most living things are heterotrophic. So autotrophs are the producers, heterotrophs are the consumers. For the producers, the main thing we need to consider at the beginning is where they get their energy from. Chemosynthetic organisms, as far as we know, are very rare. But photosynthetic organisms are very common, and they get their source of energy from the sun, from sunlight. And the sun is not only providing heat and light, but also, indirectly, letting us organize all of the chemicals that make up living things. The sun in our solar system, we call it, the name we give it is Sol, is big. It's not big in terms of stars. We've looked at this in class before, but it's really big compared to things like planets. So our Earth would fit about 1 million-ish times into the sun. It is a very large, very hot body that is doing the process of nuclear fusion. The process of fusing those nuclei is called nuclear fusion. When the sunlight reaches the Earth, some of it bounces off. Some of it bounces off of clouds, some of it bounces off of the ground, and that amount of sun that is reflected is called the albedo. So the albedo is the reflectivity of a surface. For the Earth, on average, we reflect about 30% of the sunlight that reaches the Earth. That is reflected more highly in places like snow. We can see that there's a greater reflection happening there. It is happening less quickly in areas that will absorb sunlight. So if we have sunlight going straight down into water, it absorbs it fairly well. If sunlight is hitting dark things like soil or asphalt, it absorbs much better. But clouds, snow, those things are very shiny. They have a high albedo, high reflectivity. So you can think about things that are like a mirror as being reflective, because of course they are. Of the sunlight that reaches the Earth, only about half actually gets to the surface. So this is all of the sunlight that's reaching the Earth, and what gets absorbed by the surface is about half. Some of that then gets reflected out. Some of it is reflected early by clouds. Of what's absorbed by the surface, that's warming up the ground, warming up the seas and the oceans and the lakes, some of that radiates back out, which again will go back out into space, never to be seen again. Some of it is radiated deeper down into the Earth. Some of it is carried around in the atmosphere in these curling circuits we call weather, which is complex to say the least. Of the things that don't rely on the sun's energy, we call them chemosynthetic. Chemosynthetic organisms we find mostly in deep sea vents. So deep sea vents, more than a kilometer under the sea surface, there is no natural light whatsoever. But they have heat from volcanic vents, and they also have sulfide compounds that they can use to break down into, well, molecules to make things like proteins, amino acids to make the proteins, or things like fats, things like polysaccharides or monosaccharides, or nucleic acids. All of that initial thing comes from building of sugars, and that process we thought could only be done by photosynthesis. This is a very simple image of something called a food chain. A food chain is a useful concept, but not a very accurate idea. The food chain shows that we have energy from the sun captured by producers. The energy captured from the sun that's built into plants is eaten by what we call a primary consumer, eaten again by a secondary consumer, and then a tertiary or a quaternary consumer. And that energy is going up and up and up in a food chain. This image is not, it's already crossed out, this image is not actually a chain, because although these parts do happen in sequential order, every single one of these, when they die, has some aspect of their body that is not eaten by their predators, but is decomposed by things like fungus, by things like worms, by things like bacteria or insects. The matter that is decomposed is then reusable by the producers. Our definitions again are producers, called primary producer. These ones are capturing energy either from the sun or from hydrothermal vents, although pretty much always I'm going to be talking about the sun. That is the most common way to get energy into an ecosystem. The consumers are getting their energy by eating other organisms that are already alive, or maybe they're dead, but they were alive at one point. And the decomposers are going to be decomposing dead matter. And the dead matter is going to be recycled into nutrients that are available for the producers again. So things like fertilizing soil. For consumers, we have different levels. We have primary, secondary, tertiary, quaternary. Primary means number one. Primary consumers are the first level of consumer. We can also call them herbivores. Herbivores eat plants, herbs, and vor meaning to eat. We then move on to the secondary consumers. Secondary consumers can also be called carnivores. They can be called carnivores, carne for meat. And vor again means to eat. So if things eat meat, they are carnivorous. A carnivore is something that eats other meat, but a carnivore is either a secondary, tertiary, or quaternary consumer, not just one of them. If we move on to tertiary consumers, tertiary means the third level, and a tertiary consumer would eat a secondary consumer. We also have the word quaternary consumer, and a quaternary is the fourth level. A quaternary consumer would be right here. It would eat the tertiary consumer. Some examples of food chains are, if we look at this very simple food chain, we have a plant which captures energy from the sun. That plant is eaten by an insect. Not all of the plant, but just part of it. The insect is an herbivore. The insect is also a primary consumer. The plant is a producer. The mouse eats the insect. The mouse is now a secondary consumer. The owl eats the mouse. The owl is then a tertiary consumer. So this level here is producer. This level is our primary, secondary, and tertiary consumer levels. It asks why this is not the best representation of what happens in nature, and I think the answer is obvious to you. That insect won't only eat that plant, that mouse won't only eat that insect, that owl won't only eat that mouse. There are more options available. Life is a lot more chaotic and complex. One attempt to deal with that complexity is to not look at a food chain, but something called a food web. And this food web shows an Arctic situation where we're centered on one organism. We're focused on this hare. So this Arctic hare has lots of things that it could eat. It could be eating willow, it could be eating saxifrage, it could be eating grass and sedge, sorry. It can also be eaten by many things. It could be eaten by an ermine, it could be eaten by a hawk, it could be eaten by an owl or a wolf or a person or a fox. It could also be not eaten, but eaten on by fleas. Some of its energy could go to fleas without the fleas actually killing that hare. Same for the mosquitoes. They may take a blood meal from the Arctic hare without necessarily killing it. When the hare dies, this arrow shows, I think, strictly speaking, that this dead hare is eating this hare, but this is not a zombie situation going on here. This is just showing that later in time, this hare may die. And when it dies, it may be decomposed. These blowflies down here are decomposers. And those decomposers will return nutrients to the soil for use by the other producers. This food web is also a lot better because all of these relationships are also true relationships. In the previous one, this is entirely fictional. In this one, there's one more thing that I would like to highlight, which is this area over here, the droppings from that hare. So the droppings from the hare are, of course, material that it eats. They are stuff that has some nutritional value, not nutritional value to that hare, not nutritional value to you or me, but they still have some macromolecules that could be used by other things that are alive in the world. In making a food web, it is very common to forget about things like droppings, things like feces. I'm going to stop this video here so that these videos will all be a little bit shorter.